Last section on Unit 4. So don't forget there is a test this Thursday, individual assessment on Unit 4. So 4.8, equilateral and isosceles triangles. So we have some notes, so go ahead and find this page in your Unit 4 packet. It's the bottom half of the page. You'll see the 4.6 notes on top of it. So we have some properties that we know about isosceles and equilateral triangles. So let's start with our isosceles triangles. So if two sides of a triangle are congruent, then the two opposite angles, are also congruent. All right, and what I mean by that, so if we've got these sides congruent, then I know that when I say opposite, I mean across from. So if you draw an arrow, that points to the opposite angle. So you can see angle D does not touch angle E or F, so it's the opposite one. And then opposite over here points to that one. So if we know sides D and E are congruent, DE is congruent to EF, then we know that the angle D and the angle F also have to be congruent. And for angles, it's the same thing, just completely opposite. So if two angles of a triangle are congruent, then we know the sides opposite them are also congruent. Right? So if two angles of a triangle are congruent, then the two opposite sides are also. So once again, here, if we know that these angles are congruent, then the sides opposite them also have to be congruent. So it's biconditional, goes both ways, right? If two sides are congruent, then we know the angles. If two angles are congruent, then we know the sides. Equilateral triangles, very similar, only instead of just having two sides of a triangle or two angles of a triangle, we'll have all three of them. Go ahead and pause the video after I write it down so you can copy it. Alright, so if a triangle is equilateral, then it is also equiangular. Remember, equilateral means all sides are congruent. So if all the sides of a triangle are congruent, then it is also equiangular, which means all the angles are congruent. So if we know that the sides are all congruent, then the angles, and vice versa. Alright, that's all the notes. So go ahead and turn the page, and let's work out some problems with these. So top 4 problems look like this. So we just have to find the missing angle and missing side, whatever we're looking for. So for this first one, we're trying to find the measurement of angle D. So I know that this angle right there is 50. I also know that both of these sides are congruent, which makes this isosceles. And for an isosceles triangle, if the sides are congruent, then I know the angles have to be congruent that are opposite them. So measurement of angle D, 50 degrees. It has to be the same thing as the measurement of angle E. All right, looking down at the one below it, we have an equilateral triangle this time. I know that because the sides are all marked as congruent, which means all of the angles have to be the same. So if J is 60 degrees, the angle L has to be 60 degrees as well. Remember, all angles in an equilateral triangle are 60 degrees. In fact, let's go back here and let's write that down. Angles, measurement of the angle equals 60 degrees, because that's a good piece of information to know. Right, GI. So just like in this problem, right, if we have angles congruent, then I know that the sides must be congruent as well. And it's always the ones that are opposite, so I know that side and that side are going to be congruent. So if GH is 6.3, then GI also has to be 6.3. And last one, RQ. Once again, if the triangle is going to be equiangular, that also means that it's going to be equilateral. So if QP is 4.5, then RQ also has to be 4.5 yards as well. Next page. Right, these are a bit more challenging, so let's take a look at them. So this first one, we know angle T is 50 degrees, so what is the measurement of angle U? Okay, if you said 50 degrees, you're going to be incorrect here. This one's a little bit more challenging, like I said. So remember, in an isosceles triangle, it's the angles that are opposite the congruent sides. So opposite UT is going to be angle S, and opposite ST is be angle U. So I know actually angle S and angle U are congruent. So, which means it's not going to be 50 degrees. So if I know angle S and angle U are congruent, let's call them X. And now if you remember from the beginning of this unit, what do the angles of a triangle add up to? 180 degrees. So I can set up an equation X plus 50 is equal to 180. And solving that equation, 2x plus 50 equals 180, subtract 50. 2x is equal to 130, divided by 2, we get x is equal to 65. So I know the measurement of angle U, 65 degrees. All right, NML, triangle NML. We know that this triangle is equiangular, so we also know it has to be equilateral, which means we have an equation that 40 is equal to 5t. Dividing by 5, we get 8 is equal to t, which is our answer. Nice and quick. All right, triangle XYZ, we want to find the measurement of angle X. This one's very similar to the last one. We don't actually know what X or Z are. We do know they are congruent because it's an isosceles triangle. Right, that's my opposite angle. That's my opposite angle. So then I can set up an equation and solve. X plus, remember we got our right angle here, so 90 is equal to 180. 2x plus 90 equals 180. Subtract 90. We get 2x equals 90. And then our last step, divide by 2, and x equals 45. So the measurement of angle X equals 45 degrees. And last one. All right, this one's a little bit trickier. Notice here we are trying to find BC, which is right there. So then I want to use my knowledge of a right triangle, since it's got the right symbol there, to figure this one out. So if we know two sides of a right triangle, how do we find the third? And that's going to be Pythagorean theorem. So I'm going to do a squared plus b squared equals c squared, or 1 squared plus 1 squared is equal to x squared, in order to solve for x. 1 squared is 1, 1 squared is 1, equals x squared, 1 plus 1 is 2, 2 equals x squared. Now to solve this, I need to square root both sides. And when I plug in square root of 2 on my calculator, I'm going to get x is approximately, remember it's approximately because we're doing some rounding, 1.41. So BC is approximately 1.41. Moving on. These are a bit harder problems to solve. Once again, kind of gets a little bit tougher. So go ahead and watch the next video on these problems.